Hello and welcome to the video lecture on timer interrupts in embedded C. Now in my previous videos we have already discussed about the interrupt concept in assembly. Now today we are going to discuss it in embedded C. Now first let us discuss what is the meaning of a timer interrupt or how the timer interrupt is generated. So this is basically an internal interrupt, and whenever the timer flag, that is TF flag, is raised, then the interrupt will be generated for the microcontroller. Now we know that whenever the timer reaches to its maximum value, then it will roll over back to 00, and at that point the timer will be overflow, and whenever the timer flag overflows, it will set to 1 and it will generate an interrupt for the microcontroller. If you are using a timer 0, then the TF0 flag will be raised, and if you are using a timer 1, then the TF1 flag will be raised and the microcontroller will be interrupted. But if even though your timer flag is set to 1, you have to set some particular value in the interrupt enable register, which is called as a IE register, and through this register first you have to enable the corresponding timer interrupt, and then only your microcontroller will get interrupted, and then it will stop whatever it is doing and transfer the control to the interrupt service routine. So the important thing here is you have to first enable that particular timer interrupt through the IE register. You have to load a particular format in the interrupt enable register, and then only your microcontroller will get interrupted. Now this is one table which is given for the interrupt number in embedded C. So there are total 5 types of interrupts, and the numbers are assigned from 0 to 4. So if here we are dealing with the timer interrupt, so if it is a timer interrupt 0, the number 1 should be assigned, and if it is a timer interrupt 1, then the number 3 should be assigned to the interrupt. That means whenever you are writing the interrupt service routine, then there you have to mention this interrupt number, so that the controller will identify that which type of interrupt is generated, and then accordingly the control will be transferred to the interrupt service routine in the vector table. Now this is what is the format of a IE register, that is the interrupt enable register. So as here we are discussing about the timer interrupts, so we'll see the format for timer 0 and timer 1 interrupt. So if I am using a timer 0 interrupt, then in that case I am going to make this bit is equal to 1, and along with this I am also going to make this EA bit is equal to 1, because EA is nothing but it is a global enable bit. So whenever you want to enable or disable any individual interrupt, then first you have to enable this EA bit, otherwise this interrupt will not be enabled even though you set the bit equal to 1. So this EA1 and ET01 and all other bits will be 0. So now if you can see the format or the value which is generated is, this is 8 and this is 2. So when you are dealing with a timer 0 interrupt, then we are going to load the value 82H in the I register, and if you are dealing with a timer 1 interrupt, then this value you have to make it 1 and make this value equal to 0. So this is 8, that means we are going to load the value 88H if you are dealing with the timer 1 interrupt. So once you enable or once you load these values into the I register, then only your timer interrupt will be enabled and the microcontroller will get interrupted when the timer overflow flag will set to 1. Now here we are discussing this timer interrupt with the help of this programming example. So in this example what we are doing is we are actually taking a single byte from port pin 1.7 and we are sending it to port pin 1.0, and simultaneously we are going to generate one square wave of 200 microseconds on port pin P2.5. So actually we are doing both these tasks simultaneously. So actually the controller is busy in doing this in the main program, that it is reading the port pin 1.7 and it is sending the data to pin 1.0 continuously. and simultaneously your timer is also going to run for generating the square wave of 200 microsecond on port pin 2.5. Now remember that here the square wave of 200 microseconds is given. That means this total period on and off period is 200 microseconds. So because of that, we are as we are interested in only on time for generating the delay, here we are going to divide this 200 microseconds by 2, and we are going to generate a delay of 100 microseconds. So how to calculate the count value for this 100 microseconds delay, that I have already explained in detail in my previous videos of timer. So you can refer the previous video. So if you can see the count value which is corresponding to 100 microseconds, it comes out to be A4. So I am going to load this value into the timer register. So now we'll focus on the programming part or the actual program. So let us understand the program. So the first line is a header file, that is reg51.8, which we always include for 8051 microcontroller, because all the definitions are here in this file. Now here these port pins need to be declared. So we have used the data type S bit. Switch is equal to P1.7, as I am going to read the data from port pin 1.7, and I am going to send it to P1.0. So it is indication. So it is represented by IND, which is equal to P1.0, and I am going to generate a square wave. So I have given the name wave on port pin 2.5. So I have declared all these three port pins first, which I need in my program. Now the next part is you have to write the interrupt service routine. So this is a part of an interrupt service routine. So this timer 0 is a name. This is actually one function. Interrupt service routine is nothing but is a function. ISR is nothing but a function, and this is a name given to you, the ISR. So you can give any name instead of timer 0. You can write any other name, but after that you have to mention the interrupt number. That is important. So in the previous slide, I have already shown you the table for the interrupt numbers which is used in the embedded C. So here, as we are dealing with the timer 0, here the number 1 should be written. So void, you can give any other name. I have given timer 0 and give the interrupt number. So this is what is an interrupt service routine. Now inside the routine, I have toggled this port pin 2.5 because I am going to generate a square wave of 100 microseconds on port pin 2.5. So I have just inverted this wave inside the interrupt service routine. Now in the main program, uh, I have to declare the tmod register, because I am using here the timer 0 in mode 2, because here I need to generate a delay of 100 microseconds. So mode 2 we can easily use here. So for timer 0 and mode 2, the value to be loaded into the tmod register will be 0x02. Again, the details of all this tmod and tcon I have already discussed in my previous timer video. So you can please refer those videos for these details. Then the value corresponding to the 100 microseconds delay is A4. So I have loaded that value into the TH0 and TL0 register, which is corresponding to 100 microsecond delay. And this, then I have started the timer. So TR0 is equal to 1. So these are all necessary settings that you have to do when you are dealing with the timer interrupt. And you have to enable this timer 0 interrupt through the IE register by loading the value equal to 0x82. So just now I have shown you why the value comes out to be 82. Okay. And now here in while one, your microcontroller is busy in doing this task. So IND is equal to switch, meaning is that whatever is there on port pin 1.7 will be continuously assigned to port pin 1.0. So controller is busy doing this task. So this is what is the entire program for generating the timer interrupt. Now we'll go to the keil software and we'll understand the working of timer interrupt in more detail in the debug mode. So if you can see here, the same program I have written over here in the keil. And now what I will do is I will go to debug session. Now here we will take different windows. So in peripheral you need different ports. So we'll take the different ports. You need port 2. Okay. Then we need port 1 also. So port 1 and port 2. Then we'll take an interrupt system. Okay. So this is an interrupt window or interrupt system. And what else we need is a timer. Okay. So timer 0 here we are using. So this is a timer window. So now I will go by a single stepping. Okay. Now first, when you start executing the program, it will first come to the main program, right? I will just reset this and again we will start initial value. Okay. So first it will come to the t mod is equal to, that means it will go to the main, and the first line, that is t mod is equal to 0x02 will get executed. Now you monitor this timer or counter window. Initially this mode is a mode 0, that is a 13-bit counter, which will now change to mode 2. So now you can see here, now the mode is changed from mode 0 to mode 2, that is a 8-bit auto reload timer. Then the values A4 will get loaded into TH0 and TL0. So you can see here A4 values will get loaded in both the registers. Then after that, uh, initially you can see here the status of the timer is stop, but when you execute the instruction TR0 equal to 1, it will go to the run mode. So you have started the timer, and in the interrupt system you have to enable that timer 0 interrupt. So when you execute this instruction, you can see here the timer 0 interrupt will get enabled. So you can see clearly this enable becomes 1 for this timer 0 interrupt. So all these initializations are done, and now your controller is busy doing this task. So whatever is there on port pin 1.7, it is just showing you to the port pin 1.0, right? Now whenever the interrupt generates, now when the interrupt will generate here internally, so whenever your timer reaches or rollover, or when this TF0 flag will set, it will generate an interrupt for the microcontroller. Now you see that when I am doing a single stepping, you can monitor this TL0 value. This TL0 value is continuously incrementing because at every single step your timer is actually running. So if you can see D4, D7, D9, so the value will continuously incrementing. So when this value reaches FF, you can see here, now this is FF. Now one more single step will set my TF0 flag, and the control will be transferred to the interrupt service routine. So you can see here the flag is set, but you cannot see because the frequency is in microseconds, sorry, in megahertz. So the timing will be in microseconds, so you cannot see that. But if you can see in the main program, now the control will transfer to this interrupt service routine, and now it is going to toggle this pin. So wave is port pin 2.5, so you can observe here in port P2. So see here, previously that pin status was 1 or high, now it is changed to 0. So your interrupt service routine will be executed, and then it will come out, and again the controller is busy doing its own work. Now I will run this program continuously, and if you can see, your timer is also running simultaneously, and whatever is a value on this port pin P1.7 will be given to the 1.0. So you can see here, now if you change the status to 1, this will also 1. If it is 0, this is also 0, and simultaneously this port pin 2.5 is continuously toggling whenever the TF0 will be set to 1. So this is what all about the concept of timer interrupt in embedded C. So guys, if you like my video, then don't forget to subscribe to my channel, and please share the video with your friends. Thank you guys. Thank you so much.